course, you're gonna need to have Blender installed. Currently, I'm using the 2.83 LTS version that's available for download. And first thing you need to do is to install the add-on from the zip file from the provided link. And we do that by using Edit, Preferences, and then Install. We are going to find our zip file and select Install Add-on. Since I already installed it, I'm not going to do that. Then we can search for the add-on and make sure it's enabled and that this checkbox is checked. So now if we show the sidebar by dragging this little arrow and navigate to the tab for the add-on, we can see that we have some options here. And I'm going to select the Initialize Add-on option. And what it does is it changes the user interface a bit and gives us some additional tabs here, which we are going to use. So now the next step is to import our models. These models were exported as STL files, so I'm going to choose the STL option for the import. And I'm going to select the Mandible and the right fibula. Okay, now when the files are imported, first we want to check something, and this is the physical size of these models. If we switch to the Item tab, we can see that this model is obviously a bit too large and it's off by a factor of 10. So we are going to select 0.1 as scale factor for both the fibula and the mandible. And we are going to apply the scale for the mandible and apply the scale for the fibula as well. And now we see that they have proper dimensions. Next, we want to rotate the fibula in a way that it is parallel with the y-axis, the yellow axis. So we choose the rotate tool on the left. We switch to the side view by clicking here on this circle with the x-axis. And then we click and drag to rotate. Then we can move to the top view and rotate as well. And we want to have this artery on the negative x side. So here it is positive x, in the other direction, that's this direction, it's negative x. And then we want to select the mandible and rotate it so that this part is again parallel with the y-axis. Then if we switch to top view, we can also rotate it to make it slightly more symmetrical. And this will help us make things easier later. So we have them both rotated and positioned correctly. Now we are going to switch back to our add-on tab. We are going to select our fibula object. And we have this possible incorrect orientation. This is a warning. because we haven't applied our rotation. And if we had checked the scale and left the objects too large, we would also get a warning here. So this time we are going to harvest 2 grafts. So we are going to select 2, and we are going to select the auto decimate option, which this does. It reduces the poly count of these 2 objects, these 2 meshes, and makes everything run a bit smoother. So at this point, we can save this file. In case if we do something wrong, we can come back and try again. So now when we initialize objects, we see that we get our 2 bony grafts, and now we can start to position them. If we toggle on the auto update function, we see that we have the exact copy of the fibula here, and we can see in real time when we move these grafts how they fit in the fibula, so we can avoid overlap. So one osteotomy will be here, and another will be roughly here, and we will have one graft over here and the other this way. So we can move to top view and start positioning these control points. By just moving them and rotating them. To make things easier, we can switch to the local orientation down here. Or it's going to be up here depending on your settings. Now we are going to perhaps rotate this on the axis. Now this is going to move the artery a bit lower, but it will help us shape the grafts so they fit the shape of the mandible better. Like so. And then we can again tweak the handles. At this point, we can also move the grafts on this y-axis, and they should be roughly at least 7 to 8 centimeters from the end, and we can move this graft closer as well. So at this point, I'm quite satisfied with the positioning of the grafts, and we can turn off the auto update function and save our file. The next thing we are going to do is we are going to generate our cutting planes, and here we have the cutting plane thickness, which is in millimeters, and it represents the thickness of the saw we are going to use to harvest the grafts. So in our case, we are using 0.9 as the thickness, and we are going to generate the cutting planes. Now, if we switch to the Fibula Guides workspace, we see that we have these sort of plane-shaped objects, and they represent, in a way, the material which is going to be lost when the saw cuts. Now, I'm just going to erase this. We can select our Generate Fibula Guide option, and we have our Fibula Guide. Now we just have to tweak it a bit to fit our case. And we do that by moving and scaling these control objects. So what we wish to accomplish is a guide that is held in one piece, and we can see that here this piece is connected. We can just move this a bit lower, move this slightly higher, and this result I think is okay. We can just tweak this position a bit. And this, I'd say, is all right. And we can also create some holes for the screws to hold the guide in place, and we can change the diameter of the hole. Now we are going to go to a similar process to create a guide for the mandible. we are going to switch to the Mandible guides and select the Create Mandible Guide option. And again, by moving and rotating and scaling these objects, we are going to model our guide. We are placing the screws on the part which is not going to be kept after the osteotomy. So we are all placing all the screws on the inner side rather than here and here. And 2 screws are enough to hold this in place. And we are going to now join these together. And this is it. We can again save this file and we can select our guide, hit File, Export, STL, click the selection only and export this part as an STL file. And we can do the same for the Fibula guide as well. And here we have our Mandible guide exported and our Fibula guide exported.